we're going to be talking about quadratic expressions. Quadratics look like this: ax squared plus bx plus c. And that is, yes, a polynomial. In particular, it is a quadratic polynomial. That's what we call these. Why do we care? It turns out that a ridiculous amount of stuff can be described with quadratic equations. And I believe you're taking physics, so this should look familiar to you. What is that?
Oh gosh. The force equals mass times acceleration.
There you go, right? It's one of, we even call it a law because it's so fundamental. One of Newton's laws says that force equals mass times acceleration. It turns out that anytime you have constant acceleration in your phenomenon can be exactly described by a quadratic equation. And let's think about that. Like, for instance, projectile motion. If something is being acted on by the force of gravity, well, gravity is acceleration, right? And it's on the earth, it's constant. And so constant acceleration, constant force being applied to something, it moves like a parabola. It looks like a parabola and stuff like that. Now, we're not just talking about motion of objects behaving like parabolas. If your acceleration is indeed speed, right, like your change in velocity with time, then this will describe the position of your object. It could also be applied in many other situations. Like perhaps, I don't know, you've done some calculations on your stocks and you could tell that the market forces are going to be such that the acceleration of my stocks will be constant for a certain amount of time tomorrow. And so then you could say, well, in that case, maybe X represents time. And then this bad boy right here would be the price of my stocks after a certain amount of time. Maybe the force is electrical, and we could talk about a constant force on a, say, electron. Then its acceleration would be constant, and it would be described by this bad boy right here. And so I just pulled a few examples out of my rear, and those are just very concrete realizations of this. It turns out that pretty much any phenomenon you have in the world, if you were to say graph it and it does something, it turns out that you could use these bad boys, right? You could use parabolas to approximate these things. You could say, you know what, right around here, that looks a lot like a parabola. And so we could use a parabola there. We could use a parabola right here for this part. They show up everywhere, and many problems, even ones that don't have constant acceleration or constant force, can be approximated in this way. So it's so fundamental that we get a handle on these bad boys right here. Okay, now here's the thing. We are usually, like I said, this type of, well, it's not even an equation. I haven't written an equals up there, but this type of thing usually describes something that you care about. Like I said earlier, maybe this describes my the price of my stocks, or my stock value. Or maybe we're talking about the amount of fuel you put into a rocket gives you some kind of constant acceleration. And so you could find, given a certain amount of fuel, how far has the rocket gone? And so if you're trying to send your rocket to the moon, which is 10 whatevers away, this is usually how this works, where it's like, how much fuel am I going to need to get my rocket to go 10 meters? And what we need to do then is solve for X. And this is how this shows up in the real world. Usually you have something that can be described by a parabola, or I'm going to use parabola and quadratic interchangeably. They mean the same thing. This is a parabola. That is a quadratic. It's the same thing. Usually, but this is how it works, is you have something like this, and we want to know, when is my rocket 10 meters away? And so what I'm saying is, usually the way we encounter this is we have this describe something, and we have some kind of value, we'll just call it V, that we want it to equal. Now, mathematicians and physicists and anybody who's interested in these types of questions they'll err on the side of making this as simple as possible. And right now, it's kind of like, well, if we wanted to come up with a general way of solving this kind of equation, we don't want it so that we have a total of 4 things that we have to plug in. Like this right here, I don't want a formula that's going to involve something different for every possible output value that we have. It'll be much easier if I'm only working with 3 variables here, the A, the B, and the C. So what they do is they say, you know what, we could simplify this type of thing by subtracting the V from both sides. And so we have plus C minus V equals 0. And yes, this is where we're going today. What we do is say, you know what, that right there, we could make that really simple and just call it, how about C? Just little c. Sorry, that's supposed to be a big C. Big C minus V is little c. And then in general, what we end up with are 3 numbers that we're trying to deal with here. And so this is what we're talking about, this type of thing. Okay, just wanted to give you a little bit of motivation for why we're doing this in the first place. So now let's do some actual examples here. What we're going to do, actually, so first off, I'm getting rid of all this because none of this really matters. This is just the big idea. What we want is to, given any any quadratic like this, and in particular, given any quadratic equal to 0, this equation, we want a general way of solving this that's going to work each and every time. Now, we know some special cases. When it's able to factor, when you're given something that you can factor, then we can factor it. Like here's an example. If we said that A equals 1 and B equals -1 and C equals -2, we could take that and factor it because it is factorable. We could say, okay, let's try it. I have an X here and an X here. What are my possibilities for the last?
1 and 2.
That's about it, right? And so where do I put the plus? Where do I put the minus?
+1 -2, right?
+1 -2, I believe so. Let's just check it first. Gives me that outer -2, inner +1 is a -1. Yep. Negative and a positive make a -2. And so in this case, when it's nice and easy, we can factor it and we can get the answers, which will be that when X is equal to -1, then that works. When it's equal to +2, it works. And if you wanted, you could plug those in and check it, and yes, it'll work. So that's one way that we know how to deal with stuff. But that's contingent on this original thing being factorable. It might not be factorable. But let's take a look at another example here. Let's say I have something like this. X squared minus 4 equals 0. Now this one is also factorable. In fact, why don't you factor that? You tell me, what is this factored out? How can we rewrite that?
X plus 2 and X minus 2.
There you go. I could double check that does indeed work. First, outer, inner, last does give me X squared, outer, inner cancel. +2, -2 together give me a -4. Yes, this means the same thing, which means that X is equal to what, or X is equal to what?
2 or -2.
It's 2 or 2. And we could plug this bad boy back in, either of them, plug in the -2. -2 squared minus 4. -2 squared is what?
4.
+4 minus 4 does indeed equal 0. Check. Same thing's going to work if I plug in the +2. So, okay, nice. That works. But what's nice about this one here is, yes, it happened to factor. But what's even cooler about this is we could actually just solve for x, right? When I hear solve for x, what goes on in my mind is get x by itself, right? Isolate the x on one side of the equation and get everybody else on the other side of the equation. And so we can actually do that with this one. And we've done something like this before, right? And let's think about the steps we're going to have to take. Usually when trying to get x by itself, we look at x and then ask what happens to x. Well, first x gets squared, then he gets -4. So, right, we put on our socks, then we put on our shoes. We have to take off our shoes. And so how do we undo -4?
+4.
+4 to both sides. That gives me x squared is equal to 4. Now, how do we undo squared?
Take the square root.
Take the square root of both sides. What special thing do we have to do when we take a square root? So, okay. I'm glad you hesitated because I wanted to get into this because I want to firm this up right now. There's a big difference. In fact, I'm going to just keep this like this right now. And we're going to think about what does this mean? And how is this different from an equation that's, oh, maybe something like this? They're similar, but they're different. And let's go into why. Let's imagine that I'm taking values, x input values, and what I'm going to plot is what happens when I square those input values. What is 0 squared?
0.
0. What is 1 squared?
1.
1. So we plug in a 1, we square it, we get 1 out. What is -1 squared?
1.
What is 2 squared?
4.
So we plug in a 2, we get out a 4. What is -2 squared?
4.
Also +4. Okay, so this is a parabola. This is just the parabola y equals x squared, right? And now let's think about what this means. This right here says you took some number and you squared it, and you got out, as an output, you got a 4. So what number could that have been? What's one possibility that it could have been?
2.
It could have been a 2. If I plugged in a 2, then I would have gotten out a +4. Plug in a 2, square it, you get out a 4. What's another possibility that it could have been?
-2.
-2. It could be the case that I plugged in a -2, in which case, if I squared it, I would have gotten out a +4. So when we see something like this, this means something completely different than something like this. This means, and in fact, it would probably be better to think about this as instead of an x, a y. This says you had some number and you took the, remember, this means the positive square root. That's how we defined it. We defined this thing to be basically forget about all of this negative stuff. And whenever you see this symbol in an equation, when this symbol is like given to you, it means that I took the positive square root, that we were over here on this side. So then that's why we didn't really have to worry about this. And we just said, okay, That's what that means. I could square both sides to get rid of that. No problem. 2 squared is 4. That means that your original number was y equals 4. Well, yeah, of course it was. You got a positive number because it started positive and blah, 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 blah. Long story short, when your given equation has a root in it, it's only talking about, in this case, the positive square root. Or if I did something like this, I would be talking about the other side, that it came from over here. But it's all taken care of right here in the symbols, because that is understood to be the positive square root. This, on the other hand, is a completely different monster. This says that you took a number, multiplied it by itself, and got out a positive 4. Well, there are 2 possibilities. Either it was 2 or it was negative 2. So the point I'm making, and this is something we are going to do from now on, when you have an equation and you then take a square root, watch what I'm going to do. I'm going to say, okay, I'm going to take the square root of an equation. I'm going to take the square root of both sides. Well, I know that there's 2 possibilities for where this came from. So I'm going to write a plus and a minus right there. So that's like dogma from now on. Whenever we take a square root, we have to include both possibilities of where it came from. The way to do that is on the side with your actual values, not your x value, you just write a plus minus in front of it. So one more time, just say this one more time, that any time you have something squared, in fact, I'm going to even write it like this, something squared equals something like that, and you want to undo squared, and you do this over here, we will always put plus minus from now on, because that's what it means, right? We can see that, you can see that 2 numbers will satisfy this. And so that is what this is going to do from now on. Is that clear?
Yes.
Okay, cool. So that's just something we do now. We're just going to get used to that. The square root of something squared is whatever it was. And now I don't have to worry about absolute values and stuff like that, because from now on, we're going to say, oh yeah, I know you get 2 answers from that. One's positive, one's negative. What's the square root of 4?
2.
It's 2. And hey, what do you know? We get the same thing using this method as we got from this method. And another thing I want to be absolutely clear about is that plus minus isn't a thing. This is a shorthand way of saying, hey, when you're in this situation, you are going to get 2 answers here. And so what plus minus 2 means is that x is equal to -2 or x is equal to +2. It's just a shorthand for writing all of that stuff right there. But it's understood. You squared something, and so there's 2 possibilities. It could have come from negative, it could have come from positive. It could have been -2, it could have been +2. And we could double check and plug this guy back in, right? Just like we did. Okay. Another thing we could do. Check this out. Now, this is pretty cool. So in the beginning, right, we were saying if it's possible to rewrite this so that it's factorable, that is, if you could write it as x minus one of the roots minus x minus the other root, like that, which we ended up doing just like this. If you could write this like this, then your answer is pretty easy. And what I'm going to introduce right now, like, yes, we wrote it as x plus 2 and x minus 2. But what's really going to help us in the days to come is to write it as x minus in both cases. So what I'm saying is, given 2 roots to a quadratic, root 1, which in this case is -2, and root 2, which in this case is +2, we can write it in this way. We could say x minus, watch what I'm going to do, parentheses. These parentheses are going to be your best friends. You'll see why in a little bit. Right now, it's kind of trivial, but if you write this and say, okay, I have two roots, therefore I could reconstruct the original polynomial by writing it as x minus whatever the first root is, x minus whatever the second root is. The first root happens to be -2. The second root happens to be 2. And yeah, you could see, I'm not going to go through it, but you could see that this is exactly the same thing as this right here, right? So this seems really pedantic right now to write it like this, but trust me, in a minute, this will make a lot more sense. And it's also kind of nice to see and check. You don't have to think about it. Although this isn't hard to see that, yeah, plug in a -2, that one goes to 0. Well, we're saying the same thing. It's just a little bit more. Really, what we're getting at is this form right here. X minus whatever the root is, x minus whatever the root is, will give you the roots. Okay, so let's kind of sum this back up. We had a quadratic equation, and it was possible to factor it. We factored it and found that the roots, or the solutions to that, were -2 and +2. But this one was special. We were able to isolate x to get x all by itself. And then we were able to solve, and lo and behold, we got the exact same roots. We got the same solutions. If we didn't know how to factor it, if this were something that we didn't know how to factor, we'd be able to say, well, wait a second, hold up. If these are the roots of the polynomial, you could start right here. And then first, outer, inner, last, and you'll get, well, let's see, x squared, outer is -2, inner is +2, it cancels. Minus is positive, -2 and +2 are -4. And hey, lo and behold, we have our original polynomial back. Interesting. So what we're going to do is just right now, we're just going to make some observations about this kind of thing. And this, just making observations is going to help lead us to a general way of solving these things. But right now, we're just noticing, we're just noticing things, okay? Can I erase what I have thus far?
Yes.
Okay, so I'm going to keep this the way that it is. Get rid of this, get rid of this. Now, can we factor this bad boy, x squared +4?
Yes.
Okay, what is it?
Oh, wait.
Ooh.
Yeah. What? No.
Yeah, no, not easy. Like if
Sorry.
you try, right, you're like, well, 4, maybe 1 and 4. So outer, inner, you'll have a 4 and a 1. Oh, no, that's not going to cancel. So it must be 2. It must be 2 and 2. Okay, outer, inner will give you 2x's and 2x's and plus and minus. So +1 and -1. That'll work. So +1 -1. But that doesn't give you a +4. I don't think we could factor this. This looks like it's not factorable. Well, let's try our other method. It looks like we could get x by itself. How would I get x by itself?
Subtract 4.
Subtract 4 from both sides. So we're going to start there. -4. X squared equals -4. And at this point, you go, well, I'm going to take a square root of it, but I can't take a square root of a negative number. Yes, we can. From now on, we are totally going to take square roots of negative numbers because we know how to deal with it. The same thing is going to apply, though. What did I just say happens when I take a square root of an equation? I get what?
A plus or minus.
A plus or a minus. So we have plus or minus square root of -4 right there. This, and I wanted to do this example to show that this is still true even with complex numbers. When you take a square root of an equation, doesn't matter if it's positive or if it's negative, you will get both a positive and a negative answer. That's just the nature of the beast. When you square something, the positive and the negative both work. So on the left-hand side, we have x equals plus or minus. What is the square root of -4?
I square root 2. Oh, wait.
It's just I times the square root of 4.
Right. Okay.
So I times what?
2.
I times 2. Or I like to write it as 2i. So we have plus or minus 2i. So in other words, x is either equal to 2i or x is equal to -2i. Let's try something here. Let's just see what happens. We tried this before. We got down to 2 roots. We plugged them in here and we were able to reconstruct the original polynomial. Let's see if this works. One of them is x minus 2i. The other one is x minus 2i. And in this case, it'll be easy to go ahead and drop my parentheses. So x minus 2i. This would be an x plus 2i. Oops. I could rewrite that as an x. Yeah, x plus 2i. Okay, first, outer, inner, last. What do I get with my first?
X squared.
X squared. What's my outer?
2ix.
2i times x. My inner is what?
Minus 2ix.
Minus 2ix. And what is my last? We can do this in a couple steps.
2i times I. 4i squared, which is minus 4, isn't it?
Yeah, so let's see.
Positive.
Positive.
Plus.
Yeah, so
Double
negative times a positive. This is how I like to do it. A negative times a positive is a negative. 2 times 2 is 4. I times I is I squared. But we know that I squared is -1. And so then that becomes a plus 4. The plus 2ix and the minus 2ix are gone. And lo and behold, we can factor this bad boy after all. It just turns out that he does not factor in the real numbers. We have to bring in an imaginary number. And so finally we could say, look at that. This bad boy does factor, plus 2i minus 2i right there. Interesting. Well, we're going to find out, actually, you're not going to find this out unless you take a year of calculus, a year of advanced calculus, a year of real analysis, and then when you start your year of complex analysis, you'll finally prove that every polynomial can be factored. But until then, they just say it's called the fundamental theorem of algebra. Every polynomial factors. So it is true that every polynomial can factor out like this. And those factors are exactly the roots. So, okay, so that's all right. So now maybe, so it turns out we took something that could not be factored. We can't just factor this. I couldn't have told you it was plus or minus 2i. But using this method where I was able to isolate the x, right? Get the x by itself, I was able to do. So this actually looks really promising. And this method of changing this thing, right, my original given equation, into an already factored form, that might not be so promising. So in fact, I'm not even going to worry about that for right now. We're going to forget about factoring stuff. Because if this method works, we'll be able to factor it. Like that's exactly what this is giving us. If those indeed are the solutions to that, then those are the roots of this. And we've seen that, yeah, you could reconstruct your original polynomial that way. So what I'm thinking is there's something to this method. If we could take a given polynomial, get the x by itself, we should be able to solve. Anytime you get the x by itself, you just take a square root. Doesn't matter if it's positive or if it's negative, you'll get an answer. So this looks really promising. So we're going to play with this for a while and see just what that looks like. So here's another one. You'll notice this is the same kind of idea. X, there's a little bit more going on with the x, but we could still isolate this joker right here. And in fact, I'm going to think about putting on socks, putting on shoes, and putting on boots, and see if I could just undo this. The first thing that happens to x is he gets -3. Then whatever that is, we take that and then square it. Finally, we take whatever that is and we subtract a 4. So it seems like we could go in the reverse order to get the x by itself. Let's see if that's possible. What do I need to undo first?
The 4.
Yeah, the 4 was the last thing to go on, right? Those are the overboots. We need to take off the overboots. So I'm going to take off my boots and we end up with 4x -3 squared. So now I'm looking at this and we can pretend it's a brand new problem and say, okay, x gets -3, then he gets squared. So how do we undo the squared?
Square root.
Square root. And what happens when we take a square root of an equation?
The plus and minus, right?
We get a plus minus, right? Okay, so I've taken a square root of both sides. That means now I have 2 possibilities for what that was. So undoing squared, that's why I did it in the first place. That's just a nifty symbol to show that, yeah, we're coming back. We undid squared, it gave me that. This gives me plus and minus what?
2.
Plus and minus 2. Okay, now we're down to one step. You take x, you subtract off a 3. So to get back to x, we got to do what?
Add 3.
Add 3. So let's add 3 to both sides. That gives me x is equal to 3 plus or minus 2, which of course means we have now 2 solutions. One is what we get when we go x equals 3 plus 2, which is what?
5.
And the other one is what we get when we go at 3 minus 2, which is what?
1.
1. Now, this is nice, actually, because this will be really easy to check. And let's just visually do this. I'm not going to actually write anything out, but let's just imagine that I took this 5. I'll wait for you to catch up so we could do this together.
Okay, we're good.
Okay, so imagine that instead of writing an x right here, I wrote a 5. I would have 5 minus 3 is what?
2.
1, 2, 3. Yep, down to 2. 2 squared is what?
4.
4 minus 4 is what?
0.
Hey, it worked. Hey, look at that. Let's check the other one real quick. 1. What happens when I plug in a 1 right here?
1 minus 3 is -4.
Is negative what?
1 minus 3 is. Wait, hold on. -2.
Negative 2. Negative 2 squared is?
4.
Oh man, that sounds really familiar. And look at that, right? Like something squared is 4. So that something is either 2, which is the case when we plug in a 5, or it's -2, which is the case when we plug in a 1. Okay, all right. So -2 squared is +4, -4 is 0. Good to go. Okay, now let's try to reconstruct the original polynomial. Remember what we did? We said, well, if this is a polynomial and those are its roots, we could factor it by saying x minus whatever the one thing is, x minus the other root. So x will be -5, and then x minus 1 will be the other root. And yeah, you're like, why'd you even bother with parentheses in that case? Because what we're about to do in a minute, it will be very useful to do it. So x minus 5, x minus 1. Kayla, please first, outer, inner, last this guy for me. What do I get with first?
X minus 5. Hold on, sorry.
No problem, no problem.
X minus X minus 1. 0. Okay, x minus 5. Wait, for the first one?
Well,
Oh, right.
FOIL this out to
Really?
get the original equation.
So x squared.
X squared.
Minus x. Minus 5x is minus 6x.
For a total of, what'd you say?
Minus 6x.
Got it. And then what is my last?
It's plus 5.
Plus 5. Okay. All right. So we had our roots and we did this and we got our original. Wait a minute. That's not our original polynomial. Look at that. X squared minus 6x plus 5 equals 0. That's not the same thing as this. What happened? Wait a minute. Well, maybe it is the same thing. Let's take a look at this. Let's see what this is. What is x minus 3 squared? It means the same thing as x minus 3 times x minus 3, right? So I'm just rewriting this original equation here. Minus 4 equals 0. I'm just going to work out this original equation right here. Okay. X minus 3 squared means x minus 3 times x minus 3. So let's FOIL this out. What is x minus 3 times x minus 3?
X squared minus 3x minus 3x
which is a total of what?
6x
minus 6x. Okay, and then what?
Plus 9.
Plus 9. Finally, okay, so we did that part. That was the x minus 3 squared. I just rewrote it like that. Minus 4 equals 0. So what's 9 minus 4?
5.
Oh, oh, wait a minute. That is the same thing. That's exactly the same thing, isn't it? It's just, it's written in a funky little way, right? Like this happened to be one that we could have factored, right? Because let's see, if I just gave you x squared minus 6x plus 5 and told you to factor it, you would have guessed, well, I don't know, 1 and 5, I guess, because 5. So 1 and 5, is there a way to make a minus 6? Yeah, if they're both minus 1, minus 5. Oh yeah, it does factor. But look at that. This is written in a way where the x's are not all together. In fact, starting here and trying to get the x by itself would be ridiculously hard. But starting here and trying to get the x's all by itself, well, it's almost elementary. I'm sure you're getting pretty tired of my socks, shoes, and boots analogy because it's so simple that you could see, yeah, you could easily solve for x using this method. So this makes me wonder, and this is the question, is can we take just a given general polynomial, right, something that looks like this, and change it into this kind of beast? So to be clear, what I'm saying is, given a polynomial like that, is it possible to transform it into something like this? That's what we saw, right? We have x squared minus 6x plus 5, right? Something in this form. It turns out it was possible to rewrite it like this. An x minus 3, and here I'm just using h and k just to use new letters. x minus some number squared minus some number. I wonder if it's possible to take that, and that's going to be our goal. That is what we're going to try to do, because this seems like a really good way of going forward. Now, we want to do one more example on this, and this is where your first part of your homework is going to come from. Can I erase this stuff?
Yeah.
Okay. So now in the back of my mind, I'm kind of thinking, you know what? If it is possible to take a given one of these bad boys and turn it into one of these bad boys, I should be able to solve it no matter what the values are. Hopefully, we'll be able to transform these guys into these guys. We don't know yet, but turns out, spoiler alert, we can and we will, and that's what we're going to be doing. But to really drive the point home, let's do this. Check this guy out. X minus 1 squared minus 5 equals 0. Now, let's just solve it by isolating the x. Tell me what to do.
Plus 5.
Okay, plus 5 on both sides. That gives me x minus 1 squared equals 5. Now what do I do?
Take the square root.
Take the square root of both sides, which does what?
Gives you a plus or minus.
There we go. Have to have that plus or minus over there, because there are two possibilities. Okay, x minus 1 equals plus or minus, well, square root of 5. We've been dealing with this kind of guy. This is what the whole last chapter was about. We can't reduce that anymore. That's its symbol, the square root of 5. There we go. Okay, now how do I get x by itself?
Add 1.
Okay, and that gives me x equals 1 plus or minus square root of 5. And so I'm going to write that as two distinct numbers here. Here are two distinct solutions. And what I'm going to do is I'm just going to check the first one. For your homework tonight, you are going to check this one right here. But right now, let's just check the first one and make sure it works. So this is what I'm looking for your homework, that you've written the original equation. And then you make the substitution. You say, okay, now we're going to let x equal, and I'm doing the positive one. You're going to be doing the negative one. Okay, how do we simplify this guy?
Sorry, I'm so slow at writing. Okay. 1 plus square root of 5 minus 5 0. So again. Okay. Isn't it just the square root of 5?
It is, because the 1 and the minus 1, right? If it were 2 plus square root of 5 minus 3, we'd say, well, let's get all of the things that aren't square roots together. And you'd say 2 minus 3 are together, and the plus 5 stays by itself. So that's all we're doing. We're grouping the not square root stuff together. And it happens to be that 1 minus 1, go figure, goes to 0, and you're left with a square root of 5 squared. Okay. So this is what I'm looking for your homework. The only difference is you're going to have a minus sign right there. Now, what is this? What is the square root of 5 squared?
5.
5. What's 5 minus 5?
0.
It is. Oh, look at that. It checks. It works. That is a root of the original equation. That is a solution to the original equation. Nice. Now, okay, so we've checked that. That's going to be one part of your homework for, that'll be part 1 of part 1 of your homework. Part 2 is going to be this. Only you're not going to do all of this. We're going to do it right now. What did we say before? That we could reconstruct the original polynomial by multiplying its by x minus each of its factors, or x minus each of its roots. Okay, just like we did when it was 3 and 5, we took x, or 1 and 5, we took x minus 1 and x minus 5. Here we're going to go x minus, That's why those parentheses are really important. We're going to go 1 plus root 5, and the other root here is 1 minus root 5. Okay, so let's do this. First, outer, inner, last gives me what?
X squared.
X squared. Now, this is ugly, and this is how I'm going to do it. And so watch what I do. I'm going to say, okay, outer is X times this. Well, that's a negative number, right? Or that's a negative in front of some number. So I'm going to write the number first, negative, whatever that number is, happens to be 1 minus root 5, times X. Right? And that's how we did it. If it were a 3, we'd say, oh, negative 3x, right? The only difference is it's not one nice whole number. It's just split up. But these parentheses are your best friends here. So for the inner, I'm going to do the same thing. We've done first outer. Now inner is going to be negative that number. So negative 1 plus root 5x.
Oh my gosh.
Right? Outer, inner. And now last. I'm going to have to give myself some more room. So you're going to have to imagine that there's a little equals 0 floating around over here somewhere.
Okay.
But the last is not bad, actually, because a negative times a negative is what?
Positive.
A positive. So it's got to be plus that thing times that thing. One of them is 1 plus square root 5. The other one is 1 minus square root 5, like that. And before you flip out, remember, that's a conjugate. That's going to be super easy to deal with. We'll deal with it in just a second, but it will be really easy. They happen to be conjugates of each other. I wonder if that's like going to be a common theme here as we're solving quadratic equations. Yeah, it's going to be. So now let's just multiply all this stuff out. And this is where it gets ugly, but we can do this, right? I'm going to simultaneously distribute the negative and distribute the x. So we'll have a negative 1 here, and the x is going to come in here to give me a minus 1x, or just minus x. The minus comes in here, hits that minus, and becomes plus. So we'll have a plus root 5. And when the x comes in, we'll have an x. It's one of the few times you'll see me write an x on or something on the right-hand side of a root of some sort. But are you following? Does this make sense what I just did? How I got that? So negative 1 minus square root 5 is the same thing as negative 1 plus square root 5, right? I just distribute the negative in there. And now there's an x on the outside, so I just distribute the x inside now. And so that gives me a negative 1x plus square root of 5 times x, like that.
Okay.
And that's all I did right there. I'm going to do the same thing here. Negative 1 comes in. So negative 1 times x is going to be negative x. The negative comes in to give me a negative root 5 times x. So minus root 5x, like that. And there we go. So that takes care of the inner outer right there. We'll combine them in a second. But now the last. Those are conjugates. That's easy to do. When we go first, outer, inner, last, first gives me what?
1.
The outer and the inner do what?
Cancel.
They cancel out, right? And so we don't need to worry about that. That's plus root 5 minus root 5 is gone. So what's plus root 5 times negative root 5?
Minus 5.
Minus 5. I still have an equals 0 floating around out here, but I haven't done it. Okay, so now let's simplify. X squared is the only squared guy that's there, so he's gone. Let's get the x's together. How many minus x's do I have?
2.
2. So we could rewrite that as minus 2x. Oh man, that's what's really cool about having conjugates here. One's the plus root 5, one's the minus root 5. So that gave us a plus root 5x and a minus root 5x. So they're gone. These guys cancel each other out. They are gone. Boom. Now what's plus 1 minus 5?
Minus 4.
Minus 4. And now I'm going to bring my 0 back in there. Okay. Now, let's take a look at this. Uh-oh. This thing is not the same thing as that. Or wait, is it? Let's double check and make sure that this guy is indeed that guy. X minus 1 squared is x minus 1 times x minus 1. Minus 5 equals 0. Okay, you do this one for me. First, outer, inner, last gives you what? Okay.
Okay, x squared.
Okay.
Minus x minus 2x.
Uh-huh.
And then minus 1 plus 1.
Plus 1. And then, okay, now minus 5 equals 0. And does that reduce to that?
Yes.
Yes, it does. It turns out, just like last time, they are the same. They are the same thing. And so I'm feeling really good about pursuing this avenue of approach. And I'm wondering if it's possible, if given any one of these guys, can I take it written like this and rewrite it in this form right here? That is, and I'm sorry, this is kind of backwards. Given something like this in the form ax squared plus bx plus c, can I take that and rewrite it in this form that helps me out, that I know I could solve no matter what, even if, and we've seen this, even if it's comes out to be a complex number, like was the case when we had x squared plus 4, and we took that and made it negative and took a square root and got an I, or even where the square root doesn't reduce and we're left with square roots in our answers, it looks like this method is going to be able to get it. All we need to do is show that we could turn any one of these guys into one of these guys. And it looks like we can, because I mean, at least I feel pretty confident that there's some kind of relationship between this thing and this thing. In fact, they are the same thing. So maybe we could do that in general. And that's the idea. Now, the last part of your homework is going to be to verify that this guy also works in there. So remember, 1 minus square root 5, we're going to plug into here, and you're going to show me that that equation is true. And I've already gone through what I expect for that. Now I'm going to show you what I want for the second part, which is the same thing, only what I'm about to do, I'm going to use the 1 plus root 5. You're going to use 1 minus root 5. And you're going to check that it works in this one now. And so the way I'm going to do that is say, okay, I've written this already. That's what you're going to need to write. Then I'm going to plug in this guy. And I'm going to see, is that thing equal to 0? So I'm going to do this real quick. 1 plus square root 5 times 1 plus square root 5 minus 1 plus square root 5 minus 4. First, outer, inner, last gives me 1 times 1 is 1. Outer gives me a root 5. Inner gives me a root 5. So that's a root 5 plus root 5 is 2 root 5s. Finally, the last is going to be positive root 5 plus positive root 5 is a plus 5. Okay. Now I'm going to distribute this negative 2. Negative 2 goes into here and becomes negative 2 minus 2 root 5. Minus 4 is still hanging out on the outside. We're asking, is this equal to 0? Now I can start doing some cancellations and say minus 2 root 5 and plus 2 root 5 cancel, leaving me 1 plus 5 minus 2 minus 4 equals 0. 1 plus 5 is 6. Minus 2 minus 4 is the same as minus 6. 6 minus 6 is equal to 0. It checks out. For your homework, I want to see this exact same thing, only with a minus in there. And you work it out to just prove that, yes, this 1 minus root 5 solves this equation. We know that's the same equation. We just proved that it's the same equation. So it should also solve this equation. And you're just going to verify that, yes, that's the case. That's part 1 of your homework. Any questions?
No.
Okay, so to wrap up, and boy, yeah, good time. So finally, just the last thing to notice is, had we started with this guy right here, and I said, factor, let's factor this guy out. We'd say, well, okay, help me out here, x and x. We have a 4, so what are my possibilities here for the last?
2 and 2.
2 and 2.
4 and 1.
4 and 1. So let's do 2 and 2 first. You'd have 2x and 2x. There's no way to plus or minus those to give me a minus 2x. Is there? No, you'll get a 0 or you'll get a 4. So that's not going to happen. So maybe 1 and 4. And you'd say, okay, that's going to be a 1x and a 4x plus or minus those guys together. 5 or a 3. Nope, not going to give you a minus 2. Then you'd say it doesn't factor, but we just saw that it does factor. And this is what's really cool, is we found that this thing actually does factor into this right here. And there is no way, I don't, like, look at this. You never would have guessed, looking at this number, -2, and this number, -4, and thought, oh yeah, 1 plus or minus the square root of 5. No way. There's no way you're going to like look at that and intuit that that's how this thing breaks down, but it does. And so I think it seems to me that this method is going to be very beneficial to us. We should be able to, in the end, factor anything, but we're going to pretty much just leave factoring aside, because what we're looking for are solutions to this type of equation. And the way that we're going to do it is to turn this type of equation into something like this. That is, given this guy, we are going to rewrite it like that in order to solve it. So in order to do that, I know it is 12:04 now, so we are done, but just to put the cherry on the top, your homework tonight is all about this. Well, so we want to go in this direction. We want to change this into this, right? But so in other words, when we want to learn subtraction, we first have to be very good at addition. In order to learn division, we first have to be very good at multiplication. In order to learn how to factor an equation, we first have to know how to multiply out something like this. If I gave this to you, Before we learn how to go from this direction to this direction, we spend a lot of time going from this to that to get a feel for it. So that's what our homework is going to be about. We are going to be looking at this thing right here. We are going to become really familiar with what happens when you take an expression like this and square it. That's all your homework is about. You're just going to have 12 of these guys to square out, and you're going to square them. And we're going to look and see some patterns that emerge of what happens when you do that. In the same way that you learn multiplication before you learn division, that's precisely what we're doing. We're going to look, we do want to go in this direction, right? We want to take something like this and turn it into that. But in order to do it, we're going to spend our time turning these things into this thing so that we can get a better feel for how we do it in reverse. Does that make sense?
Yeah.
Okay, cool. Good luck with your stuff.
Thank you.
I will email you the homework and it will be posted on the website too.